Here means they're connected. Here no connection. So these are the wires. Two wires are there. So call this is 1, 2, 3, 4. 1, 2, and 3, 4 are not connected. Here 1, 2, and 3, 4 are connected. In exam, either they can use this method or this jump method. Okay, no. Now we have to find out the RAB. So from division of current, so let the current I1 and I1. Look at the resistance here, R and R. This is so current enters positive, leaves where it enters positive and negative, that one. So look at the junction C. Look at the junction C and D. Are they similar? From C, what happened? A resistance R and R. Three resistors are there. Three also, three resistors are there. Again, one resistor connected between them. So definitely what happened? If you write the potential difference formula, VA minus I1R minus VC equals 0. VA minus R minus V equal to 0. With this, VC equal to V. Similarly, the similar condition, what we can bring it for the same thing. I'll write it directly. So look at again writing KVL. So similarly, what happened? Therefore, similarly, VD equal to VF. So now what is the thing? If any resistor directly connected across the equipotential point, so what you should do? You should remove that resistor. So I think you do. I brought different situations. 2 points, same potential, and if they are not connected by any direct resistor, what you should do? Those 2 points you have to make common. But across equipotential point, if a resistor is directly connected, you have to remove it. No current flows through it. This is what I put yellow color one. No current flows through it. So after removing that circuit, it will be. Then the total circuit will appear for us like this. This everything will become 2R by 3. Because how they are, you look at this is R, this is R, no? This R plus R, 2R. 2R parallel to R will be 2R by 3. I just try to, instead of drawing many circuits, then there only identified few. Then after this should be the okay, we ended up with this much here. What to do? We have to calculate that RAB, no?
R by 5, sir.
How much?
6R by 5.
Yeah,
6R by 5.
6R by 5 will come. Okay, this resistor I should remove, no? Sorry, yeah, they should not be there. This should be the network. There's resistors C, D. It should not be there, no? C, D, F, this is C. So how to find out this? If you want to redraw it, again, this will not help you. This will not help you much. This will not help you much. Yeah. Can we, any other alternative method? I'll go for the current distribution. So here, rather than current distribution, I'll find out the potential at C and D. So can I go for potential at C and D? Because there's only alternative, So what I do is I'll apply voltage across A and B. I'll find out expression for current through it. For that, I need potential at C and D. So here I'll assume potential equal to V, that one. So here I'll read out the circuit. Let's come directly to the only this one. So here it will be, the total circuit will be, after redrawing, I'll bring one external cell. Let it be EMF. Let it be equal to V naught. Let me write it. No problem. This will be V naught. This will be 0. So then what will happen? We can assume now the potential set C and D, like earlier what we did. Then I'll get potential at C and D. So here what I needed, I just needed this current I1 and this I1. No? So what is the total current that will be flowing through the circuit? Same current should flow. So if what is the total resistance RAB? RAB, can I use this formula? V naught by 2I1. Somehow you can find out the I1 problem is solved. I1 in terms of what? I1 in terms of V naught. How to calculate I1 in terms of V naught? Directly come for this like a cell. So if I can get this potential VC, I think problem solved. No? So let me assume the potential VC, let this be VD.
We can also do by equipotential points, sir.
Which are equipotentials?
C and A, D and F,
C and
E.
that one only, no? That only? Because I removed resistor.
Further, we can join those 2 points, sir, like we did in previous problems.
So after removing again, what happened again in Vistron network? Did we join them? Check once. After removing that, because the galvanometer, there was some resistance, let's assume. There is TQ potential. Then we removed that galvanometer. Did we made again them common? No, I think there's a basic rule, no? If 2 points are at same potential, if any resistor connected, remove that resistor, finish over. Again, don't make them as common point. I think this was the basic what we follow in the network analysis here. Okay, this one. So what was the rule we made? If any resistor directly connected to equivalence, remove it. Again, we didn't say that after removing, make them common point. I think that will be a very bad idea. No book can suggested that till now what I have come across. Maybe you end up with answer, but it will not work out in all cases. A good example is Vistron network. You remove that resistor across where galvanometer is there. After removing that, find out the effective resistance, make them common and find out you will get the answer different. So something the idea is wrong, no? Okay, fine. This will be, so how to write right now? So can you write nodal analysis for VC? So I think we have to write for VD and this will be 0 volt. Let me assume. So VC minus V naught by R plus VC. What about the potential? Potential of VC equal to VE, no? And potential of VD equal to VF. So here one more conclusion, VC equal to VE, but don't make them common point because you remove. So therefore again this should be VC minus VF by R plus Vc minus Vd by 2R by 3 equal to 0. And as we know, Vc equal to, this should be equal to Vd only. So this will be Vc minus V naught by R, as Vf equal to Vd. This is similarly, let me write equation for this, because Vd is needed. No, I'll write equation for Vd also. So Vd minus Vc by 2R by 3, Vd minus Ve by R, Vd minus 0. Why 0? Did it? One more step, I'll write it. By R equal to 0. So Vd minus Vc by 2R by 3 plus Vd, Ve equal to Vc, it is R plus Vd by R. Solving this, Vd and Vr are getted. Once if I get Vd and Vr, then how to calculate I1? How to calculate I1?
V naught minus Vc by R.
Yeah, that one, that formula I'm going to apply it. Yeah. Now look at this. What is I1? So after getting Vd and Vc, solving this equation 1 and 2, I don't know which methods you used and brought the answer. I'm not very particular about the way some of you gave answer. I think within short time how that answer came, God only knows what method you applied. Some of you gave answer immediately. I don't know what method you applied. So this should be, so after getting Vc, then V naught minus Vc equal to I1R. So I'm going to get the value of Vc in terms of V naught. I'll get I1 in terms of V naught. Okay, got this? So that I1 I'll substitute here, then I'll get RAB. Will be 1.2R. We have to further solve it. So this is like a, it'll become like a really, like a big networks will come somewhere, Wheatstone network, some equipotential. Sometimes we say I brought the nodal analysis. So what is this equation? It came from nodal analysis. But the basic core idea is this one, RAB. RAB is equal to V naught by 2I. What is the effective, what is the, like how much of current the cell will push? It will push 2I1, no? And that only will branch out and the same 2I1 will return back. So what is the total resistance seen by the cell? It should be like V naught by 2I1. So I will be, okay, 2I1. Yeah, that I1 will come in terms of V naught. Substituting that will get RAB. This, I think what I discussed problems, like especially this one, no? It's about only learning purpose, huh? Nothing to do with any exams. Nobody will ask you. The learning purpose. So try to don't just follow the book, because some books they're given slightly, they are at same potential. How they are at same potential, we don't know. How they brought answer, we don't know. So don't just blindly accept. There should be some reasonable method.